What's up everybody? This is Cakez, and this time we are going to add in localization to the game. This time is actually the second to last tutorial, as we are mostly done with the engine. Now you should be able to make your own games in this engine moving forward. Obviously there's some stuff that is missing, but for the most part the core idea of the engine I hope came across, and you should now be able to take this as a reference point or starting point, or maybe as a resource on, well, how could I do certain things? And I hope that I achieved this with this tutorial. First I have to fix a mistake from last time. I accidentally wrote platform sleep instead of platform sleep. So I want you to go, and I said that in the last tutorial as well, but I didn't actually push it. I just wanted to tell you that I'm doing it this time. So over here I changed that to a platform, and I'm also going to do these in the header file. If the recording accidentally destroyed this platform sleep, then I'm very sorry about this. I accidentally have a platform sleep here. We're going to change this to a form. Platform sleep, that's correct for the function, and then that should work. Next I want you to go over into the gamestate.h, because in order to make a localization system we need text, because that is what we do. It's different, it's text in different languages. In order to do that I want to make a main menu, or like a very beginning of a main menu, where we just have the play button that we already have in the middle of our scene. In order to do that we need a game state, and I'll put that right above the game state here. Right now we will only be able to go into the main menu and stay in the level, and then we obviously have to add that to the game state structure too. Okay, now that we are able to differentiate between the two, we need to go into the game.cpp file. In the simulate function we have to now differentiate between being in the main menu and actually running our game or being in the level, and that looks something like this. We have our delta time, and then we switch on the game state, and if we are in the main level then we update our level, but if we are in the main menu then we just update the main menu, which means that we need to take this entire part here and extract this out into its own function, but without the actual UI part. So without this, we want to update the player, update the solids, the moving part, all of this stuff here up until this very last brace, if I'm correct. Yes. All of this stuff has to go into its own function, and above the simulate function we're going to create this void update level that takes in a float delta time, and then we are going to paste everything in here, and there should be no errors when pasting. Just a simple overview again. We're going to update our player, our tiles and our solids. It's a big function. Now we also need to be able to update the main menu, and we're going to create this above the simulate function again. Void update main menu takes in a float delta time. And then we take all of this from below the simulate switch statement and we extract this out into the main menu. The first thing I would like to change is this trace. Instead of actually tracing something out, I would like to change the game state to go into the level when we click the play button. And I would also like to replace the text with a different text that says a generic string Celeste clone, and we'll get to that in a second, on the position 56 and 20. That is hard-coded. That is because we don't have centering of text yet. It is written in black, has a font size of 2 and is using a layer. That is something that we're going to add in now as well. And so at this point it would be great if we know how to get these strings. And so in order to do that I want you to go into source and create a new file called that texts.h. If you want you can create a pragma once. I'm not doing it because I'm only including this in the game, because only the game needs access to this. The engine doesn't care about the text that we have. The engine only cares about, well, which characters do I have to draw? So what do we have in this file? First of all, I made a very simple example. We have a localization English and a localization German. And then in this enum we have a localization count. This is very important because if you look down below we have a string array that is holding however many strings we have times however many localizations we have. So if we have 2 localizations, in our case we do that, and 2 strings, then in total we should have 4 strings, which means below this localization enum we also have an enum for strings. And you can see our first string, the Celeste clone right here, and then I made another one just for fun, the string made in C++. And so in order to understand how this works, first we have to keep track of what current localization we use. The reason why this is a global variable is because down below we have this very short string function that is literally just an underscore and takes in a string ID. So it is very easy to type in code and we don't have to do string function with localization and string. It's a little bit annoying to type that all the time. So in order to to get rid of all of this typing, I store the localization as a global variable, and then we will be able to use that or change that global variable in code later. So you can make a save game and then basically load that in on runtime, and then you switch that with like some sort of checkbox or combo box, and then you just save that to a file, and then every time you load the game, this gets loaded in and changed. So, but first let's look at this init strings function. This needs to be called by the game every time the game gets recompiled, and in order to do that I want to skip ahead real quick and go into the game.cpp file. First, at the very top, I would like you to include the text.h, and then I want you to go down into the initialization part of the game right here where we update our game, and then whenever we reload the DLL, I want you to call the function init strings, just so all of the texts or all of the strings get filled in. And unless you have a very high amount of strings, this should be fine. Now, this init strings function, unfortunately we will not be able to handle umlauts. For those of you who like or know German, we will not be able to handle this yet. This is not a perfect system, as I've stated before, but the good thing about C++ files, C++ can do UTF-8, and when I'm able to fix this problem in my own game, which I'm doing in C++, then I will update this tutorial later on. But for now, this is the extent of my knowledge. So how do we do this? We take our localization into the strings array and we use it as a base point. So basically we use the offset 0, and then we offset that by what type of string we have, which is the string Celeste clone here, and then that gets assigned to a C string. And this string is an array of characters that gets stored in our dynamic library in our game DLL. And so if we have more strings, the DLL will be bigger, of course. But again, since we do not have that many strings in this game, and usually when you're making 2D games that are not story driven, you won't have that many strings. It is fine if you don't have that many strings. And so our goal is to fill in all of these strings into the array based on what localization we have. So if we have 2 localizations, we need to fill in the first one and then the second one. And then when we want to access a string, we supply a string ID, and then that indexes into the current localization times the string count plus the string ID. And so that is how we can get our strings back from the texts. So if we take a look at the DUI text function here in the update main menu, you can see that I call the underscore and I take in the string Celeste clone, and then I just fill in the material, font size and layer. That will draw me a text if we can get the layer, that is. And that is something that I wanted to add in this time, because now we're going to generate a UI menu. And to make it easier to work with UI so that you can tell which one is actually on top and behind, we needed to add in, or I needed to add in the layer. That means we have to supply this layer to the GPU, which currently we don't do. And that means we have to change to the shader header. In the shader header, we have our transform, and that transform can now take in the float layer. If we were to only supply this float layer, then this transform would no longer be 16 bits aligned. If we were to use this transform on the GPU now, it would add in an artificial padding here. And that means this padding gets filled in by the first component of this vector 2, since we have an array of transforms. And so the more transforms you have, the more the data gets corrupted. If we add in an artificial or an extra padding here, and we will probably use this in the future, then this just gets left over as 0 and is fine. Unfortunately, we have to do this because we are using a storage buffer object in OpenGL, but that also holds true for Vulkan. I have encountered the same problem when using storage buffers there as I have with OpenGL. It seems to be something related to the GPU. If you know more about it, feel free to tell me in the comments, but I'm pretty sure you guys won't. Let's just put the padding here. Okay, I've told you about it. It's very important. And move on. And by move on, I mean we switch to the rendering interface now. And we start by adding in the layers. Right at the very top here where we have our structures, we have a layer for the game and a layer for the UI. And then we also have a layer count. And that gets important right now, because we need to calculate the layer between 0 and 1. Remember, 0 is at the very beginning of the camera and 1 is at the very end, the near and far planes. So I want you to go into the renderer utilities section, and then at the very bottom here, we need to add in the getLayer function. Let me scroll this up a little bit. This getLayer function takes in, of course, one of our layers and a sublayer. And the way this works is very simple. First, we convert our layer to a float layer, and then we generate this layer step. And so what we do here is we take the range from 1. Basically, we know that we have an entire spectrum from 0 to 1 to work with. is. So we take 1 and divide that by however many layers we have. In our case, that is 2, which means we will have 1 divided by 2, which is 0.5. And then in between those steps, I want to have baby steps, but to never reach the next one. So if we start at 0 and we add in a lot of tiny layers, I never want to reach 0.5. And that is the 1000 right here. So essentially what we do is, if we have a layer, then we take that layer step. If, for example, in the game that would be 0, we multiply that by the layer step, which is 0.5, which is also 0. And then we take the sub layer, which would be, I don't know, 10, 20, 30. And then we divide that by 1000 to get a very small fractional value. We could even divide this further, but at some point it is very imprecise. And so I'm setting the hard limit to at most 1000. That returns us then a result between 0 and 1. Now, having a way of getting the layer, we also need to store and then supply that to the GPU, which means that both the draw data and the text data need to have a handle on that. On the draw data, a float layer, and on the text data. And now that we have this on the draw and text data, we also need to supply that to the transform whenever we draw, for example, a quad or a sprite. But you might have noticed that the draw quad function and the draw sprite function both generate a transform on the stack. And so they both fill in essentially the same data with a few differences. And so I thought of a cool way of merging these things together, and that is a function called getTransform. We add that to our utility functions. This getTransform function takes in a sprite ID, a position, and a size that can be left 0, and a draw data. The reason why the size can be left 0 is so if we don't supply one, then we just take the size of the sprite, which means we have to have an operator on the vector2 that gives us a boolean back whether the size has actually been filled in or not. And so in order to do that, we have to switch to this, and then among the operators we add one additional one, which is called the operator bool, takes in nothing and then returns whether x and y are unequal to 0. So if one of the components is not 0, then the vector is filled in. We can then save this and switch back, which should give us no more error here. So what do we do? First we get the sprite, then we check whether we supply a size or not. Then we generate a transform on the stack like usual. We get the material index from the material, we get the position, make sure that it's centered, we set the size, we set the atlas offset of the sprite, we generate the atlas offset based on the animation index, we set the size of the sprite depending on the sprite's size, then we set the rendering options, and at the very bottom we set the layer. Now obviously we have to change the draw quad functions to accommodate. The top one can be left unchecked because it just takes in a transform, so we already have one, but the draw quad and draw sprite functions both change. Draw quad takes in a position and a size and draw data now that we didn't have earlier. That is because we would like to have a quad in a different color, for example. And then we call down to the getTransform function that takes in a sprite height, the position and the size, and the draw data. And then we just add that to the transforms. And we do a similar thing with draw sprite. Instead of generating the transform ourselves, we call down to the getTransform function again, only this time we leave the size empty, which would then take the sprite's size instead of the size that we supply here. And then we also add this to the transform as well. So nothing much different, but you can see that the draw sprite and draw quad functions have gotten much simpler. And that is really cool because now we only have to change one place if we want to add more stuff in the future. The other draw sprite function, which just takes in an integer vector2 for the position, does not need to be changed because it calls down to the draw sprite function. And then one last thing, so we don't have an error later, in the draw UI text function we also have to supply the layer. So make sure that you add the transform.layer equals textData.layer here as well. We are not going to touch this getTransform because this is dependent on the glyph, and therefore there's not an easy way to merge this with the other getTransform function. So it's easier to just leave it as it is. Now that we are almost done with the rendering interface, you might have noticed that the game CPP file is still red, and that is because the draw text function takes in a character pointer, but it now fills in a const character pointer, which means it would lose the const qualifier. So in the draw UI text function, we need to make sure that we are only accepting const characters. Same as before, I'm not very comfortable with const yet because I mostly stick to C, therefore we have to make this change here, otherwise it would have been there beforehand. Now that we have these two const qualifiers, we actually have no more errors in the game and we should be able to run. So you might notice that we have our Celeste clone, we have our play button, and then you might notice that these two things are flickering to the left and to the right. So what is happening here is we are still drawing our game and we are drawing our UI. And the game is not being updated, therefore the positions, the previous and the current position, are flickering because it's interpolating between nothing. On top of that, they will always be drawn. This is the downside of this fixed update loop. We always draw the UI, we always draw the solids, we always draw the player, and we always draw the tile set. In our simulate function, we now have a switch statement that, depending on the state of the game, only updates the level or updates the main menu. Therefore, if we always draw the game as well, obviously we do more work than needed, which in this case is fine because it's a 2D game. But if we don't make sure that the UI draws something on top of that, we can see the game, and we don't want that. So I want to draw a full screen UI quad that just covers this up, and then we can keep drawing our game because it's fine. We're not updating it at all. We're just drawing some sprites. So in order to do that, in the simulate function where we update the main menu below the text, I would like to draw a full screen quad. You might notice that this is called do UI quad. It is positioned in the middle of the screen, aka world width and world height divided by 2, and then it draws at world width and world height divided. And then it draws a quad that is world width and world height big. The material color is a cool blue color that I just got from the internet, and then we also supply the layer 0, which is supposed to be behind the text and the button. The button doesn't have the layer yet, so we should switch that. The updated version of the button should look something like this. We are in the middle of the world. Our color is the color green when we hover, and the layer is 10, which means it is also on top of this full screen quad, but we don't have this do UI quad function. For that, we need to switch into the UI.header file. By the way, I know this is a lot of setup, and so if you need the time, skip through the video slowly and then see what I'm doing, and also take your time to look at the repository. It will be updated with the current version so that you can take a look at what changed. So yeah, let's switch to the UI.h file, and then here at the very bottom, I want to add another handle, and let me scroll up a little bit. The do UI quad function takes in a position, a size, and draw data, and then just assigns these things to the UI element and adds that in. You might have noticed there is a size field now, which means that the UI element at the very top, we also have to add that in. That is a vector 2 size right here. And then at the very bottom, that should be fine. And then also in the game, we should be able to do a quad. Building and running the game right now requires a restart because we have changed the data structure of the states, meaning the state of the UI changed because we changed the data structure of the UI element. So we have to make a hard reset in order to see the changes. And now you might notice that there is no UI quad showing up at all, and that is because of layering. The layer is not actually being used in the shader, which means we have to go to the vertex shader, and then instead of using 0 here, we have to supply the transforms layer. Now that will still not show up because it is an actual game quad. And the reason why this happens is because we add in a do quad, but at the very bottom in the update game loop where we draw the UI, we draw sprites. We don't draw UI sprites, meaning they are not being sent to the UI sprites array. We would like to have a draw UI sprite function, similar to the functions that we have for the game in the rendering interface. So below the rendering functions, I'm going to add in a section for UI rendering. And let me scroll this up a little bit again. Basically what we're doing here, and that is mostly a copy from the ones above, the draw UI sprite function is exactly the same copy, but when we get the transform, we add to the UI transforms array. Drawing a UI sprite is the first step, but we also have to supply the UI element size if we want to make sure that it is properly drawn. If we now run the game, we get a menu that looks like this, and if we click the play button, we are in the game. We are actually already there, we're just missing a way to go from the game back to the menu. And in order to do that, I would like to add into the game.header file another game input. I would like to call that pause. And then in the game CPP file, where we have the initialization part, this is where we add our key mappings. I would like to map the pause key to the escape key, or the escape key to the pause action. Now that we have this, we can go into the simulate and then the update level function right at the top here. If we press the pause action, then we would like to switch to the main menu. Now I quickly want to clean up a little bit more, just a couple of tiny things, like for example at the bottom we draw our stuff from the player and the solids and the tiles, we don't use any layering at all, and we don't have to, but I would like to add this anyways. Like for example here, when we draw the solids, I would like to add in a layer. We just get the layer of the game using 0, and we do that for the player as well. We get the layer of the game 0, and then of course we do that for the tile set too, which means they will all be on the same layer. And now if we click play, we get into the game, and then we press escape, we get back to the main menu. And we can now test if this actually works. So for example, below the initialization of the game, we can just by hand set the localization to German and then see it switch to clone, which is the German word of clone. And there you have it. This is how you can do localization in a game engine in C++. Not the perfect solution, obviously, but a solution nonetheless. And so yeah, I hope you enjoyed this almost the last tutorial. The next one will actually be the last. And yeah, if you did, please leave a like and subscribe. It really means a lot to me because these tutorials take a lot of time and effort to make. I'll see you in the next and last one. Until then, peace!